Thanks, Travis. Yeah, my origin story is a bit different to Mackenzie's in that when I moved to Las Cruces, New Mexico, I moved to the coldest place that I'd ever lived. And it was the first time that I'd seen snow as well. And the reason that I moved there was to develop tools so that we could better understand dust source areas and where wind erosion is occurring on landscapes in ways that can inform management on the ground. So today I'm just going to give a very high overview of what we know about dust emission source areas and how they might be changing. And then, like Mackenzie, I'm going to wrap up with a slide highlighting some of the key questions and repeating some of Mackenzie's questions as well. So I wanted to kick things off by sort of establishing the global dust cycle, and that's the term we use to describe the set of processes of dust emission, transport and deposition around the world. And these processes are really important for a whole range of different Earth systems and society. The US is a pretty small player in the global dust cycle. It doesn't emit very much dust relative to the Sahara, for example. But the regional impacts, like dust on snow, are really important. And so it's important that we better understand them so that we can manage them and adapt to them. Just to give an example, in the US, a recent estimate of the cost of dust on health is around $13 billion a year. And we've recently developed a study sort of looking at the full range of economic costs of dust in the US, which puts it about $154 billion a year. So dust ranks very highly among the billion-dollar disasters that are impacting the country. So it's really important that we get a good handle on what's going on. Little bit of science here. I thought I'd start by describing what is dust emission. And the set of illustrations on the left here show the three main mechanisms by which dust is lifted from the soil surface. So the first at the top is aerodynamic entrainment, where soil particles are lifted directly by the wind and there's little interaction between those particles. And the other two processes, saltation bombardment and aggregate disintegration, are the most efficient mechanisms of releasing dust from the surface. You need a great force to release these fine particles. Both of these processes, we basically have sand-sized grains or aggregates bouncing or hopping, saltating along the surface, fragmenting on impact and releasing fine particles, which can then be suspended and transported some distance downwind. And we measure and we model these processes as fluxes of sediment. So the saltation flux, this hopping, we describe as a horizontal sediment mass flux. So that's the amount of sediment that's being blown by the wind across the landscape between two sort of imaginary goalposts. And the dust emission, which is what we're really interested in here today, we describe as a vertical mass flux of sediment. So that would have units of grams of dust per unit area of the land surface per unit time. And areas that frequently produce dust we typically refer to as dust hotspots, and these tend to sort of qualitatively have a common set of characteristics, which is that they tend to be located in areas with a dry, arid climate, with sparse vegetation and fine sandy soils. And we can change where on the landscape our dust hotspots are by changing the vegetation in some way, which enables the winds to be more erosive, and by disturbing the soil, which can increase the availability of fine particles to be lifted up and moved by the wind. One of our problem solvers, Mike Dunaway, who's not with us here today, recently published a nice summary that qualitatively described where dust hotspots might be in the southwest of the US. And there's a really interesting coincidence of places with a particularly arid climate that have fine sandy soils, which overlap in the Four Corners area to the southwest of our snowpack, where we're seeing the big impacts of dust on snow. And these areas also tend to have sort of persistently low vegetation cover. So the map on the right-hand side of the screen there shows just a snapshot of bare ground cover from the Rangeland Analysis Platform for 2023. And the darker areas are essentially where we have more bare ground, which correspond with areas that are drier and have these fine sandy soils, and tend to be where we see dust emitted from the landscape. we can use satellites to build a picture of how much dust is in the atmosphere, and from that infer where our persistent dust sources might be. So this is a map produced by Paul Genou and colleagues a little over 10 years ago, and it shows the percentage of days per year with dust optical depth above a nominal threshold. And dust optical depth is just an indicator of how much dust is in the atmosphere above a point on the surface. So big things that jump out are the Great Plains, an area that are affected by the Dust Bowl, so that's still a dusty area. And then through the southwest, the Chihuahuan Desert is a big dust-producing region, Sonoran, Mojave, Great Basin deserts, and then Colorado Plateau. So this shows dust in the atmosphere. It doesn't show where dust emission is occurring. If we're lucky, our satellites capture a nice image of the dust event in action. And the two images on the right-hand side of this slide show a major dust event that produced sort of the dust on snow episode in April 2013. We have a morning image and an afternoon image where you can really see the intensification of the dust plume as the wind speeds increased. We can identify sort of the point sources on the upwind side of these plumes, but what happens beneath these plumes is really hidden, and we don't have a good understanding of just how much of the landscape was producing dust in these big events. It's probably safe to assume that a lot of the landscape had some susceptibility to wind erosion and was contributing to the dust loads. Really across the rangelands on the Colorado Plateau, but we also see dust on snow contributions from the Chihuahuan Desert, from sources in northern Mexico and around our other sort of regional deserts. Within the Four Corners area, really Little Colorado River Basin is a persistent dust source. The area sort of Chinle Valley and then sort of northwestern New Mexico between the 491 and 371 there, in that sort of region 3 that I've got highlighted there. And we see these source areas popping up persistently over time in this kind of imagery. We can use field measurements to try to get a better handle on this, and I guess a really important point I'd like to make in our understanding of dust source areas is that direct measurements of dust emission fluxes are basically non-existent. So I coordinate the National Wind Erosion Research Network through the USDA. We have 3 sites that we've managed to produce consistent dust emission measurements from over the last 10 years. We're looking to expand those measurements, but at the moment, there's really nothing to go on in terms of actual direct measurements. Travis has done a really neat study linking measurements of the horizontal or saltation sediment flux to climate, soil properties, and vegetation, and used that to model spatial patterns of sediment transport by wind in part of the Colorado Plateau. And again, Little Colorado River Basin, sort of Chinle Valley pop up as potential dust sources using this kind of technique. To some extent, we can use regional models to understand what's going on, but models like those used for our national air quality forecasting and that kind of thing prescribe source areas of dust. So they have no utility for understanding the dynamics. How's vegetation changing? And how is that influencing where dust might be coming from on the landscape? USDA, with our collaborators, we've been working on a couple of different dust models that attempt to resolve the effects of vegetation with greater fidelity, so we could represent how changes in the cover and structure of plant communities influence dust emission. And this map shows a summary of the mean annual dust emission flux from 2001 to 2020. And our usual suspects sort of pop up in the Four Corners area and Chihuahuan Desert, but we've also got some sort of spurious source areas in Wyoming and central New Mexico, which really reflect the challenges of accurately predicting dust emission without forcing the models to prescribe certain source areas. So we're still working to improve these sort of regional models to get a better handle on what's going on. And this sort of leads us to the question of, well, are things changing? Is it getting dustier in the West? Often you'll hear the narrative that things are getting worse, it's getting more dusty, but is that really the case? Ariel and Evans, a couple of authors, published a couple of years ago a really nice study of the interagency monitoring of protected visual environments, or improved data set. So the dots on the maps here show improved monitoring locations, and they measure fine dust concentrations. And they found that over the last sort of 20 years, there was an increase in the frequency of low concentration dust events, but we really haven't seen an increase in the frequency or intensity of high concentration events that would contribute to these big dust on snow sort of episodes. With our models, we can start to unpack some of the reasons behind these trends. So the map here is just a cutout from the model map of dust emission that I showed earlier, with the green box highlighting our four corners source areas. And interestingly, we've seen sort of in the first decade here, from 2001 to 2010, a pretty persistent increase in dust emissions across the region. But from 2011 to 2020, we've seen a pretty consistent decrease in dust emissions. Using a model like this, we're able to start to unpack why we've seen these kinds of changes. You know, is it attributable to an increase in wind speed, or a decrease in the amount of vegetation, or an increase in wind speed that's overcome an increase in vegetation? But we're not yet at the point at the regional scale of being able to link these to the ecology of the ecosystems, which is really required if we're going to link source areas to management options. So to wrap us up, I've sort of got a broad set of questions here. Some of these were covered by Mackenzie, and these are sort of on the dust emission side of things, really critical questions that we need to address if we're going to address source mitigation. Starting with, there's a real dire need for more monitoring of dust emission across the landscape. There's a need for long-term monitoring, both to understand what's going on in the atmosphere, the air quality impacts, but also to improve our models to get better prediction of the emission fluxes that we can then transport to snowpack and improve our forecasting on that side of things. As Mackenzie mentioned, there's a real need to extend our understanding beyond the last 20 years. There are opportunities to do that using different remote sensing platforms, but we haven't yet produced the inputs to the dust models that we would need to enable us to do that. Under what conditions do high dust years occur? We know that they're generally coincident with drought, which is linked to the El Nino Southern Oscillation. There's a possibility that that increase and decreasing trend in dust emission that we've seen might be linked to the Pacific Decadal Oscillation, but we really haven't teased out all of these interactions at this point in time. So there's a lot that we can learn there. We don't really know how wind speeds are changing and how land cover, or the ecosystem changes that we're observing across the West, might be interacting with wind speed changes to influence dust emissions. And we don't have a good handle on necessarily the ecology and the ecological dynamics of our dust source areas in ways that can inform management. Christina's going to pick up on that and talk about some of the tools that we can use, specifically looking at how we might leverage some of the existing monitoring programs that we have to enable managers to assess wind erosion and dust emission risk on landscapes and feed that into identifying sort of appropriate mitigation options.